Section 4.2, exponential functions. First question, we're given f of x, which is equal to 2 to the x power, and we want to find f of 4. Now, what you want to remember about exponential functions is that the variable is in the exponent. That's why they're called exponential functions. We want to evaluate this exponential function. We want to find f of 4. You're going to replace the x in the equation with the power of 4, and you can use a calculator, scientific, or graphing, either one, to find 2 to the 4th power. And we get 16. Okay, 2 to the 4th power, that's 2 times 2 times 2 times 2. 2 multiplied by itself 4 times. So f of 4 is going to be 16. For question number 2, again, we have an exponential function. In exponential functions, the variables are in the exponents. We want to find f of negative 5. We want to plug that in, so we want 4 to the negative 5 power. If you use a calculator, you're going to get a decimal for an answer. So if you do 4 raised to the negative 5 power, you typically will get a decimal answer. We want to write this as a fraction by pressing on the graphing calculator, convert that answer to a fraction to get 1 over 1024. Now you can do this without a graphing calculator. A scientific should do that as well. Or you can use the laws of exponent. You can write any exponent that's negative. You can make it positive by writing it as a fraction. So 4 to the negative 5 is the same thing as 4 to the positive 5 in the denominator with a 1 in the numerator. So you can evaluate 4 to the 5th power, and then that number is going to go in the denominator. So it's just an alternate way of finding or evaluating that exponential function. Let's check our answer and move on to question number 3. For question number 3, we're given an exponential function. Again, the variable's in the exponent, g of x, which is equal to 1 half to the x power, and we want to find g of 3. So this is 1 half, all raised to the x power, where x is 3. 1 half to the 3rd power is, you can use a calculator, and you can write this, I would use parentheses around the fraction 1 half, and you're going to raise it to the 3rd power. As a decimal, you get 0.125. Convert that to a fraction to get 1 over 8. Okay, again, you can also use the rules of exponents to share that exponent. This is the same thing as 1 to the 3rd over 2 to the 3rd. And 1 to the 3rd is 1 times 1 times 1, which is 1. 2 to the 3rd is 2 times 2 times 2, which is 8. So another way of writing that, getting the answer, is of 1 over 8. Let's look at number 4. Here we're given g of x, which is equal to 1/8 all to the x power. We want to find g of negative 2. This is 1/8 to the negative 2 power. You can use the rules of exponents. You can distribute that power. You get 1 to the negative 2 power over 8 to the negative 2. Anytime you have a negative exponent, you can make it positive by rearranging the terms. 1 to the negative 2 has a negative exponent. We bring that to the denominator, becomes 1 to the positive 2 power. This 8 to the negative 2 power is going to move to the numerator to become a positive exponent. And 8 squared is 64, and 1 squared is 1. So we get 64 for our answer. Now you can also do this with the calculator. We're going to find 1/8 raised to a negative 2 power. We get the answer 64. And we can check our answer, 64. Okay. Alright, so you can work it out by hand using the properties of exponents, or you can use a graphing calculator. It's always nice to check your work with a calculator. Let's look at question number 5. Here we have a function f of x is equal to 2 to the x, and we want to find f of 7 over 2. F of 7 over 2 is going to be 2 raised to the 7 over 2 power. Now, anytime you have an exponent that has a fraction in it, that can also be written as a square root. So we can write this as, we can write it as 2 to the 7th raised to the 1/2 power. And that's the same thing. Anytime you have a 1/2 power, that's the same thing as the square root of 2 to the 7th power. Now, either way you do this, you're going to get a decimal for an answer that we want to round to the nearest thousands. So we are going to need a calculator here. We can type 2 raised to the 7 over 2 power. It's a good idea to put that whole exponent in parentheses. And we get 11.3137. Or you can even do the square root of 2 to the 7th power just to check that you get the same result. So when we round this to the nearest thousandth, that thousandths is 3 decimal places. So what is normally, we have 11.313708.5. We're going to round to the nearest thousandth, so that's going to be 3 decimal places. Because this number, 7, is greater than 5, we are going to round it up. So to be 11.314 would be our rounded answer. And we can check that. Okay, let's look at number 6. Here we want to graph the equation y equals 7 to the x power. Exponential functions, this is an exponential function because there's a variable in the exponent, will often look like an exponential growth or exponential decay type of function. So it's either going to maybe start low and grow exponentially higher, or it's going to start high and then decay exponentially, get lower and lower, eventually sort of kind of flattening out. So one way to sketch a graph is to make a table, x's and y's. I'm going to just do maybe a couple values for x. If you plug in -1 for x, you get 7 to the -1 power, which is 1 over 7. Plug in 0, 7 to the 0 power. Anytime you have a number raised to the 0 power, that's going to be 1. And then you plug in 1, 7 to the first power is 7. So we have 3 points that we can sketch, and we're going to connect those with a nice smooth curve. The first point here, -1, 1/7 is a point on the graph, 0, 1 is a point on the graph, and 1, 7 is a point on the graph. We are going to plot a couple points, a -1, 1/7, really close to the x-axis, 0, 1, and 1, 7. Now these 3 points kind of curve around. You can plot even more points if you want to just be sure that what this graph looks like. If you plug in 2, you get 7 squared, which is 49. In fact, if you try plugging in 2 and graphing it, it's going to be so far up the page. It really, really gets high there. And you can plug even other values for x, for example, 7 to the -2 power. That's going to be 1 over 49. It's going to be really, really close. So the graph will tend to flatten out and on the x-axis and then grow exponentially. You can compare our graph. It looks like this choice here. You see that exponential growth. That is typical for these exponential equations, either starting out flat and growing exponentially, or maybe starting off really high and then decaying exponentially, kind of getting slower and slower. So I'm going to choose that one and check my answer. Alright, let's look at graphing question number 7. We're going to graph y is equal to 1/3 to the x power. You can make a table of values. Just a couple, -1, 0, and 1 for x. If you plug in -1, you get 1/3 to the -1 power. That's the same thing as 3. Plug in 0, 1/3 to the 0 power is 1, and 1/3 to the first power is 1/3. So this corresponds to 3 points on the graph, -1, 3, 0, 1, and 1, 1/3. Plot those. -1 up 3, 0, 1, and 1 1/3. And we have this graph. Oops. Okay. -1 3, 0 1, and 1 1/3. The graph should decay exponentially. So it starts off really high and will flatten out towards the x-axis. If you need to plot a few more points to confirm that, you can certainly do that. And it looks a lot like this choice here. Make your selection and check your answer. Okay, if you want to compare how this looks on a graphing calculator, you're going to go to the y equals, clear whatever's in there, and we're graphing in parentheses 1/3 raised to the x power. And I start off with the standard zoom, 6 for standard zoom, and you see the growth, the exponential decay function. Okay, so with these, making a table, plotting a few points, and you can also check with the graphing calculator.